6.8 Graphing Radical Functions. So we're going to talk about to graph square roots. You have to be able to explain the transformation and state domain and range of the function. First, square root graph. This is always the parent function of the square root graph. What makes it the parent function is this square root, and it's just of the one variable. So nothing else is happening. There's no numbers, there's no multiplying by -1. That's why this right here is the square, or the parent function. So when I look at this parent function, you can always look at the graph to help you write the domain and range. So if I'm looking at the domain here, domain is all x numbers. So in this graph, it starts at 0, 0, and then it goes only to the right. So that means my domain x is going to be greater than or equal to 0. Nothing less than 0. Why nothing less than 0? Because you can't take a square root of a negative number. So then I look at my range. Again, range is always going to be all your y values. So if I'm looking at this graph, the lowest point on this graph I go is the 0, 0. And then I only have numbers positive, so y can only be greater than or equal to 0. The reason why that y can also only be greater than or equal to 0 is because of the domain restriction. We can't have any negative numbers for y because we can't have any negative numbers for x. So this is always what we're going to base our domain and range off of. So how does it change from my parent function? Again, this is your parent function, and this is what the graph looks like for your parent function. So now we're talking about transformations. So again, my parent function is my square root of x. Now what would happen if I have a -1? So this is like being multiplied by a -1. Well, what my graph would look like, it would flip my graph upside down. So it would go upside down, and this is what it would look like. So if I'm looking at my domain for this, my restrictions for x are still the same. X is going to be greater or equal to 0. But if I look at my range, my y is flipped. So y is going to be less than or equal to 0. Because in all these numbers here, it's below the y or the x-axis, so y is negative. Because this -1 out in front makes it negative. So now if I have a number out in front, now two things. I could either have a number that is greater than 1, so let's say if it was 10, or else I could have a number that is going to be less than 1. So let's say if it's going to be 1/2. It's going to change the way the graph looks depending on what the number is. If the number is greater than 1, it would make it feel like it's pushed out. It's going to get really high. So it's going to be a factor of a. It's going to make it larger. If it's going to give you a number less than 1, it's going to shrink it or push it down closer to the x-axis. But you still have that arc. And depending on what that number is out in front, it's either going to be a large arc if it's greater than 1, or else it's going to be a small arc if it's less than 1. And then we have a horizontal shift and a vertical shift. So I'm going to write up two equations. One, what if there's just something on the inside of my equation? So if I just had, let's say, x minus 2. And then they say in the inside of my equation, it's underneath the square root. That's what I mean by inside. This is going to be a horizontal shift. Now, if it shows -2 on the inside, it's actually going to give you a positive shift. So if my original point was going to be 0, 0, that would be a shift of 2 to the right. So I would just redraw that point at 2. And then the arc is still going to be the same. So this is what the graph would look like when it would just have a horizontal shift of 2. Now what if I have a number on the outside of my equation? Meaning it's not underneath the square root, but it's going to be, let's say, plus 3. On the outside, it's a vertical shift, meaning this 3 moves it up 3. So if I start at the origin and then move up 3, this is where my new point is at. And again, the arc stays the same because there's no multiplying by any number. So those are all the different transformations we have. So now we're going to practice. So the first thing we're going to do here is say the transformation. So if I look at this function, I have to think, is it on the outside or inside? This number is on the outside of the function. That means it's either going to move up or down. So in this case, since it's negative, it's going to move down 2. The reason I would say state the transformation first is because that's going to help you draw the graph. Because you're always going to be basing it off of the original. So in the original, this point is at 0, 0, but now the transformation I know is down 2. So I can move down 2, and I'm going to plot that point and draw the graph. Now that I have the graph, that's going to help me state my domain and range. My domain here is all x numbers. So if I look at just my x's, just looking left to right, x is going to be greater than or equal to 0. And if I look at my range, range is all your y's, y is going to be greater than or equal to, now the smallest point here, the smallest point that I have on this graph is where I start from. The smallest point here is going to be negative 2. So it's going to be all numbers greater than negative 2 because it's going up. So for the second one, again, I look, this is on the outside of my graph, but it's a plus 2. So I know I'm going to go, or plus 1. So I'm going to go up 1. So again, you start the origin because that's from your original. That's your parent function. Go up 1, plot that point, and draw the graph. Now when I state my domain and range, my domain does not change because it's going to be x is greater than or equal to 0, but my range does change. Y is going to be equal or greater than or equal to, my smallest point on this graph is a positive 1, so it would have a positive 1 there. Try to draw the next two problems by yourself, stating the domain and range. Those should be your two answers with your two graphs. Now for the next two problems, it's still the same 3 steps. Is it on the inside or outside of the function? So for this first one, this is on the inside of the function. On the inside of the function, it moves left or right, but it's opposite that's shown. So if it says positive 4, we're not going to move right. It's opposite what you would normally think. So I'm going to move left 4. So if I graph this, I move left 1, 2, 3, 4, and draw my arc the same. So I'm looking to make sure that this point is plotted correctly and their direction is plotted in the right direction. Now when I look at my domain and range, my domain here, my farthest left that it goes would be x is going to be greater or equal to negative 4, because that's where my point starts. My point at the x starts at negative 4. And my range here, y is going to be greater than or equal to 0, because that's the lowest that I go is y is 0. So if I look at this negative 1, again on the inside of the function it's opposite, so it's going to move right 1. So I'm going to just plot that point first and then draw my direction, and that's going to start with my domain. My domain here is going to be x is going to be greater than or equal to 1, because that's the farthest left that I go. And my range here, my y value, is going to be y is greater than or equal to 0, because my farthest down I go is 0. So attempt the next two problems and check your work. So those should be your transformation, your domain and range, and what your graph looks like. So what is this graph? And I'm also going to have to state the transformations and also going to have to state the domain and range. Now, if you want to, when you see something like this, you can put this into your graphing calculator first, and that might help you. But when I'm looking at this function, I see that there's multiple things going on here. This is going to do something to the graph. This is going to do something to the graph. This is going to do something to the graph, and this is going to do something to the graph. So first I'm going to go over the transformation. So what is each thing going to happen? So for the first light blue, this right here, if there's a negative number out in front, that's going to flip over the x-axis, or else you could also say a reflection. The 1/2 there is going to shrink it. So I'm going to have to say a vertical shrink. Remember, that's just kind of pushing it closer to the x-axis. This 3 is on the inside of the function, so it's moving left or right. On the inside, it's always opposite that's shown, so it's going to move right 3. And the positive 1 is on the outside of the function, so that's going to move it up 1. So now I have all of my transformations. So if I were to graph this now, remember, when I look at my original parent function, this point always starts at 0, 0. So really what I'm going to do is transform this point. So these first two depend on the direction of the point. These second two depend on how does the point move. So if I have the point normally at 0, 0, but now it's going to move right 3, 1, 2, 3, and up 1. This is my new point. So I have that on there, and then I have the vertical shrink and the flip over the x-axis. So in my original, I would move up and to the right, but since it's a flip over the x-axis, I'm going to move down and to the right. And the vertical shrink means it's going to be smaller. It's not going to be as wide. So instead of having a large arc, it's going to be closer to the x-axis. So this is kind of what it looks like. So now I'm going to state my domain and range. So my domain here, and really when you're doing the domain and range, you want to focus on this point right here. The domain x is going to be greater than or equal to. So when I look at this, what is the largest number, or I mean the smallest number that x is going to be? Smallest number here is going to be a positive 3. So x is going to be anything larger than a positive 3. And then my range, and this is where I'm looking at my y's. My y, here since it's pointing down, it's going to be a little bit different because y is going to be less than or equal to, because it's moving downwards. So y is getting smaller. And the largest number that y is going to be is a positive 1. So again, if you want to do this on your graphing calculator, that can help you, but you're still going to have to know what is the transformations, so all of these four, and be able to state the domain and range. When you're graphing this on a test or quiz, I'm making sure that this point is plotted correctly, so in the exact point, and that you have the direction and the shape correctly. So that is all for today. Have a wonderful evening.